Welcome. In this presentation, we will explore the concept of database refactoring. Database refactoring is improving database design without changing its semantics. So, what exactly is database refactoring? It's a small change to a database schema that improves its design while preserving both its behavioral and informational semantics. Think of it as making small, incremental changes to your database structure to improve its quality, maintainability, and performance. The key is that it preserves existing functionality and data meaning. It's an evolutionary approach to database development. Why should you refactor your databases? Firstly, it helps in technical debt reduction by eliminating design flaws and shortcuts that accumulate over time. This makes the database easier to maintain and extend. Secondly, it leads to performance optimization, improving query execution times, reducing resource consumption, and enhancing overall system responsiveness. Thirdly, refactoring enables schema evolution, adapting the database structure to changing business requirements while maintaining backward compatibility. Finally, it results in improved data integrity, strengthening constraints, normalizing relationships, and ensuring data consistency across the database. There are several types of database refactoring. The first one is structural refactoring. These are changes to the physical organization of database objects without affecting the logical data model. Examples include renaming tables or columns, splitting tables, and moving columns between tables. The second one is integrity refactoring, which involves improvements to data quality and consistency by adding or modifying constraints. Examples of this include adding check constraints, introducing foreign keys, and implementing unique constraints. The third type is data quality refactoring. These are changes that improve the quality of existing data without changing the schema structure. Examples include standardizing values, fixing inconsistent data, and consolidating lookup tables. Lastly, we have performance refactoring, which includes modifications that improve database performance without changing functionality. Examples include adding indexes, denormalizing for read performance, and implementing materialized views. Let's walk through the database refactoring process. The first step is to identify. Identify database design issues through code reviews, performance analysis, or maintenance difficulties. Look for signs like complex queries, redundant data, or performance bottlenecks. Focus on areas with high maintenance costs or frequent changes. The second step is to plan. Design the refactoring strategy with clear goals. Create a detailed plan including schema changes, data migration steps, and application code updates. Estimate the impact on dependent systems. Break complex refactorings into smaller, manageable steps. The third step is to test. Create comprehensive tests to verify that the refactoring preserves data integrity and application behavior. Include unit tests, integration tests, and performance benchmarks. Use production data samples to validate your refactoring approach. The fourth step is to implement. Execute the refactoring in a controlled environment. Apply schema changes, migrate data, and update application code. Monitor for issues during implementation. Consider using database migration tools to automate inversion changes. The fifth and final step is to verify. Validate the refactoring results against expected outcomes. Run all tests to ensure functionality is preserved. Measure performance improvements and verify data integrity. Document the changes and benefits for future reference. Here are some common database refactoring techniques. First, rename column, which involves changing a column name to better reflect its purpose while maintaining data and relationships. The SQL command to achieve this is alter table customers rename column cust_phone to phone_number. Second, split table, which is dividing a table into multiple tables to improve normalization and reduce redundancy. The SQL command to achieve this is create table addresses as select ID, street, city, state, zip from customers. Third, add constraint, which is implementing data integrity rules to ensure consistency and validity of data. The SQL command to achieve this is alter table orders add constraint fk underscore customer foreign key customer underscore ID, references customer's ID. Fourth, introduce calculated column, which involves adding a column that derives its value from other columns to simplify queries. The SQL command to achieve this is alter table products add full underscore price generated always as base underscore price multiplied by 1 plus tax underscore rate. Database refactoring isn't without its challenges. One major challenge is data migration risks. Moving large volumes of data between structures can lead to data loss, corruption, or inconsistency if not carefully managed. To mitigate this, create comprehensive backup strategies and implement transaction-based migration scripts with validation checks. Another challenge is backward compatibility. Maintaining support for existing applications while evolving the database schema can be complex and error-prone. Implement database views, synonyms, or abstraction layers to shield applications from structural changes. Downtime concerns is another challenge. Schema changes often require locking tables or database objects, potentially causing service disruptions in production environments. Use techniques like dual writes, blue-green deployments, or incremental migration strategies to minimize downtime. Lastly, testing complexity is a significant challenge. Verifying that refactoring preserves all existing functionality and data relationships requires extensive testing across multiple systems. Develop comprehensive test suites including schema validation, data integrity checks, and application functionality tests. To ensure successful database refactoring, consider the following best practices. Firstly, version control everything. Keep all database schema definitions, migration scripts, and data transformations in version control alongside application code. Treat database changes with the same discipline as application code changes. Secondly, small incremental changes. Break complex refactorings into smaller, manageable steps that can be tested and deployed independently. Many small refactorings are safer than one large refactoring. Thirdly, automated testing. Create comprehensive test suites that verify data integrity, schema correctness, and application functionality. If you can't test it, you shouldn't change it. Fourthly, measure performance impact. Benchmark before and after refactoring to quantify improvements and ensure no performance regressions. Data-driven refactoring decisions lead to better outcomes. Fifthly, document changes. Maintain clear documentation of schema changes, migration procedures, and the reasoning behind refactoring decisions. Future maintainers will thank you for explaining why, not just what. Lastly, backup strategy. Always have a reliable backup and rollback plan before implementing any database refactoring in production. Hope for the best but plan for the worst. Let's consider a case study of an e-commerce database refactoring. Initially, the e-commerce platform was experiencing slow query performance and maintenance difficulties due to a denormalized database design with redundant customer data across multiple tables. The team implemented a phased refactoring strategy. First, they created a normalized customer data model. Second, migrated data incrementally using temporary tables. Third, implemented database views for backward compatibility. As a result, the query performance improved by 65%. Database size reduced by 40%. Maintenance time decreased by 50%, and new feature development accelerated. To conclude, incremental refactoring allowed for continuous operation with zero downtime, while significantly improving system performance. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.